All right, so welcome back. Welcome back, all the NEET aspirants, all the students here. We are going to begin with one another session of units and measurement of 11 physics that is going to come into your NEET 2024 examination. So, guys, I am Dr. Shankar Sir, your very own physics educator, and I here again welcome you all in this series of units and measurement. So, guys, in the last session, we have been talking about, we have been talking about the, in the last session, we have been talking about the significant figures, and we have seen that what are the of, rules of the significant figures, right? Right? In the last session, we have seen this, right? That what are the rules to identify the significant figures? Yeah. Okay. Do you remember that? So, what were those rules? What were those rules that were be there? That were there for identification of the significant figures. Okay. So, in the last session, what we have seen, guys? In the last session, we have seen about the significant figures. About the significant figures, right? So we have spoken about that how we can identify significant figures in our measurement, and understanding the significant figures will help you understanding the error analysis as well. So the rules first, I'll quickly brief you with those rules. So what were those rules, guys? What were those rules? So the first rule was all the non-zero numbers, all the non-zero numbers were significant figures. Okay. Okay, first rule. Second rule, the trap zeros, that is zeros between, that is the the zeros between the significant figures are always significant. Okay. Okay. What was the third rule? The third rule was that the trailing zeros, sorry, the initial zeros or the leading zeros are never significant. Okay, just giving you a brief about the last session, right? Just a brief about the last session. Okay, and what was the next rule? So the other rule was, first rule was non-zero digits are significant figures. Second rule was trap zeros, that are the zero between the significant figures are always significant. The third rule was that the the initial zeros or leading zeros are never significant, right? Fourth rule was the trailing zero or ending zero are significant if they appear after the decimal, right? Fifth rule was that 10 to the power something, okay, 10 to the power something, that is order of magnitude, is never significant, right? Sixth rule was that if it is in a formula or an established constant like refractive index, like the formula I have quoted you in the last session, like surface area, that is 6a square, parameter, that is 4a. So in these terms, 6, 4, etc., these are always having infinite significant figure, because we understood that the significant figure is something in a measurement. What is the number of digits we are pretty sure about, we are certain about that these are the significant, these are correct measurements. Okay, this is the significance of the significant figure, right? Okay, and the last rule was, while you convert the unit from one system to another system, you must keep in your mind that during the conversion, the number of significant figures must not change. So this way, in the last session, I told you that 4.0 kilometer is equal to 4.0 into 10 to the power 3, 10 to the power 3 meter. It is not equal to, so this is correct conversion, okay, in terms of this significant figure, because in both of it, the number of significant figures are same. Okay, this is wrong. 4,000 meter is wrong. Okay, Okay, 4 into 10 to the power 3 meter is also wrong. 4 into 10 to the power 3 meter is also wrong, right? Okay, 0.4 into 10 to the power 4 is also wrong because in each of these cases, okay, so in each of these cases, how many significant figures are there? So we have three significant figures in each of the cases, right? We have three significant figures. We have two. Sorry, in these each of the cases we have only one significant figure. Okay, so the number of significant figures, the number of significant figures must remain the same during the measurement. Must remain the same during the measurement. Okay. Okay. So now in today's session, what we got to do. So in this today's session, guys, what we are going to do in this today's session, we are going to talk about calculation that involves the significant figure. So this is a very very important thing to understand. This is a very important because why it is very important because see later on we will be proceeding with the error calculations and all. So there, the calculation with respect to the significant figures will be very important. So calculations in significant figures. So when I say about the calculations, what I need to do, what are the basic calculations? So we need to plus, we need to do minus, we need to do multiplication, we need to do subtraction, we need to do division. So all these are simply the calculations involved in the significant figure. Now, do try to understand this also. Do try to understand this also. That first of all, we need to understand the rule of rounding off. So, see, rounding off means what? So, I'll tell you. So, see, basically, so have you ever used the calculator? So, if you use the calculator will do some rounding off of figures. Okay. Okay. So, for example, so see, I'll tell you with the help of a question or some number of questions. So, what are the rules of rounding off? So, let us take some problems and through see. As I say always, that physics can be better understood when you apply it in terms of questions. Because when you are applying the concept while you are learning it, definitely you are going to be more and more comfortable in that particular concept. I believe. Okay. Now please understand this. So we have this, what we have. So let's suppose that we need to round off to two significant figures. So I'm going to give you some numbers, some values, and we try to convert them to two significant figures. Okay. So let's start with the first. So let's suppose we have 3.72. Okay. Okay. So how many significant figures are there in this? So in this, we have three significant figures. Now, when we have three significant figure here, we want to reduce it to the two significant figures. So we need to do the rounding off. Very, very important. So, sir, you would say, Arey, sir, this is very, very easy. We all know it. It is going to be 3.7. Why so? Why so? Because, sir, we very well know this concept that when we want to round off to a digit lesser after decimal, so if a number is less than 5, we'll keep that number as the same. Okay, please understand this. See this too. Okay, I hope you know it, but if you don't know it, please understand this. So this is the 2. Okay, so you want to round off to two significant figures. Now the question is, what is the problem here? You have two options. Either it will remain 3.7 or you will write it 3.8. You can't do it 3.6. Okay. Okay. So what is you have to choose? What is that you have to choose? So you have to choose whether you keep it as 3.7, whether you raise the 7, or whether you keep it the same. Are you getting my point? So when I say 3.72 and you want to round it off to two significant figures, the question is, the choice you have is that whether you are going to keep 7 as the same, or you are going to raise it to 8. Okay. Now see, if the term after that number that you are thinking to remain the same or to increase it, you have to check this number. So if now please understand this, if less than 5, if less than 5. So when it is less than 5, guys, when it is less than 5, so we all know it, when it is less than 5, you have to keep that 7 as 7 only. You don't have to increase. Okay, you don't have to increase it. Now please understand this. Now let's suppose we have the second question. We have 3.76. Okay. Now we want to reduce this to two significant figure. Two significant figure. Two significant figure. Now how we are going to do that? How we are going to do that? Now please understand this. So this is certainly greater than 5. This is certainly greater than 5. Now, if it is greater than 5, you must go with the second thing, that is, you raise the 7 to the next digit. Okay. Okay. Like, for example, if I say we have 4.73, we have, let's suppose, 7.38. Okay. Now, how you are going to round them off to two significant figures? So, sir, very, very easy. Sir, we are going to see. So, when we want to reduce it to two significant figures, the question is whether to increase. See, it will be 4 point, it will be 7.5. Okay, 7 point. Okay. Now, the question is whether you have to increase this 7, whether you have to increase this 7, or whether you have to keep this 7 as it is. So you have to check the next number to 7. So this is 3. This is 3. So when this is 3, guys, when this is 3, guys, so when this is 3, you are going to keep it the same, because obviously it is less than the 5. Now here, this is 7.38. So 8 is the number, obviously, 8 is the number, obviously, greater than 5. So when 8 is the number greater than 5, when 8 is the number greater than 5, what you have to do? You have to increase this 3. You have to increase this 3. Now let's suppose we have 11.271. Now what you are going to? So how many significant numbers are there? So I'll just make it like this. 1.271. 1.271. Now you want to, because last was, if I write 11, so you reduce it to two significant figures, it will become 11 only, right? Okay. Now we have 1.271. 1.271. Now what is you are going to call it when you want to reduce this thing to, when you want to reduce this thing to two significant figures, how you are going to do it? How you are going to do it? So sir, how we are going to do it? We want to reduce it to two significant figures. So 1 will be there. We are not going to change this one. So 1.271. 1.271. So we are having this question that this is 2. This is 2. So when this is 2, guys, when this is 2, obviously this is less than, this is 2. And the question is whether to keep this 2 like it is, or you want to make it 2 to 3. Okay. Now for that, you have to see the next number after 2. After 2, what is the next number? So the next number is 7. So this number 7 is what? It is greater than 5. So when it is greater than 5, you can increase this 3. You have nothing to do with this one, right? You have nothing to do with this one. I hope this is fine to everyone. Okay. Now I was saying, let's suppose 11.812. Now you want to convert it into two significant figures. How you are going to do that? How you are going to do that? So if you want to round it off to two significant figures, you will going to write 12, because here the question is about this one. The question is about this one. Okay. Now the next number to this one is greater than 5, so you are going to increase that number. Okay. I hope this is clear. So this is very easy thing. We already knew it. Before you told us, we already knew it. And I believe that almost 60-70% of the students who are maybe watching this video would be knowing this fact that this happens this way anyways. Now, now let's suppose we have a number 3.75. 3.75. Okay. Now, what is the problem? I want to reduce this to two significant figures. Now, sorry, sir, what is this? What is this? So sometimes what happens? So when someone asks this to us, then what we do? We don't know. Okay, now here is the interesting thing. Please try to understand. Now, if it is the 5, the problem lies with it. Because see, sir, if it is less than 5, we would have kept 7 as the same. Okay, and we would have written, that means if I write it here, so if less than 5, if this number would have been, okay, so if and would you are using, so this is not a grammar class, just you try to understand my terms. So if this digit would have been greater than 5, it would be 3.8, right? It would be 3.8, no problem at all, sir. Now, if this digit would be, if less than 5, it would be 3.7. Okay, there is no other answer. But sir, this is exactly 5. Now it is exactly 5 when it is what, sir? It is exactly 5. If exactly 5, the question is now what to do. If exactly 5, the question is what to do now. Okay, what to do now? Now, sir, we are trapped, we are stuck, we have reached an impasse, right? Right? Now, what to do? So now there can be some cases. Please understand. Please understand it very, very carefully. So we have 3.75. Let's suppose 1. Okay, we have 3.758. We have 3.756. We have, let's suppose, let's take something else. 6, 6, 5, 2. We have 4.659. We have 651. Okay. Okay. So you want to reduce it to two significant number, right? Two significant, not three significant, two significant. Okay. Okay. So if it would have been three significant number, the first one would have become 3.75 because afterwards it is 1 which is less than 5. 3.758, then 8 is greater than 5, so it would have been 3.76. This is 3.756. If you wanted to reduce it to three significant figure, it would have become 3.76 because 6 again greater than 5. Then we have 4.652. It would have remained 4.65. 4.659 would have become 4.66, and 4.651 would have been 4.65. Right, but here the question is reduce it to two significant figures, not three. Two significant figures. That is the thing. So for two significant figures, so the problem is we have 5 here. We have 5 here. Now, since we have 5 here, we don't know what to do with this 7 or what to do with the digit previous to or before this. What to do with the digit before this 5? Now, please understand. Please understand this. If, please understand, very, very important. So, if digit after 5, if digit after 5 is non-zero, remember it is non-zero. It can be greater than 5, it can be less than 5, it can be any number, but it has to be non-zero. Okay. So, if digit after 5 is non-zero, raise the digit before 5. Please understand, very important concept. Raise the digit before 5. Okay, before 5. Now see, we have to reduce it to two significant figure. The problem is that we have 5. Now please understand this. So see, After 5 in this, we have a non-zero number. So you have to increase the digit before 5. Here also, after 5, we have a non-zero number. So we have to increase this 7. Again here 6 is a non-zero number, so it is non-zero, so we have to increase this 7. You don't worry whether it is greater than 5, it is greater than anything, but it has to be non-zero. It has to be non-zero. If it is non-zero, you can raise the digit prior to the 5. Now here what it is? It is 4.652, so it would become 4.7. Why so? Because that the digit after 5 is non-zero. Here it is 4.659, so you can say it is 4.7. Again it is 4.7. Okay, so just you have to see whether after 5 the digit is 0 or non-zero. And if it is non-zero, guys, if it is non-zero, you can raise the digit before 5 by one number. Okay, by one. Okay, by one. But sir, we face a doubt here. Okay. Okay, so if I would have been at your place, the immediate question must be coming in my mind, sir, what if it is 4.750? What if it is 4.750? What to do? What to do now? What to do now? Sir, we want to reduce this to two significant figures. We want to reduce it to how many significant figures? Two significant figures. Now, what is I need to do? What is I need to do? So the first fundamental is not gonna work. This thing is not gonna work. Now, this thing is also not gonna work. Now, what is going to work here? Now, please observe this. Please observe this. Now, whether to increase this 7 or keep it same, for that, if after 5, now, if I'll write it here, if after 5 there is 0, if after 5 there is 0, what you need to do? You need to check, because you don't have any other option, you need to check the digit before 5. You need to check the digit before 5. Okay, before 5. So when you are going to check the digit before 5, when you are going to check the digit before 5, there can be two things that can happen here. If you are going to check the 0, if you are going to check the digit before 5 and after 5 it is 0, there can be two things. It can be a odd number, it can be a even number. Okay, okay, so please try to understand this, what I am saying. So this rule will come in force when this thing happens, that you want to reduce to two significant figure, you want to reduce to two significant figure, and after 5 we have 0. So after 5 we have 0, so we don't know that whether to increase the 7, whether to decrease, whether to keep it the same. Decrease is never the option. Okay, now for that what you have to see. So here you have to see, so this is 5, you want to reduce it to two significant figures, so now you have to see this. Okay, see this. Now it can be 7 or it can be, let's suppose, for sake of understanding, let's suppose we have 4.650. We have 4.650. So this is odd, obviously, and this is even. This is even. Now please try to understand it. Please try to understand this. If in this case, when after 5 there is a 0, if in the case after 5 there is a 0, if in this case where after 5 there is a 0, you are seeing the digit before 5, and if it is odd, increase that digit by 1. Okay, if it is odd, increase the digit. Obviously, always we do increase by 1. And if it is even, keep it same. If it is even, keep it same way. Okay, keep it same way. Understood? Understood? So now in this case, when you see 4.750, when you see 4.750, so when you see 4.750, you want to convert it into two significant figures. So what is going to happen here? So we are going to have it written as 4.8. Why, sir, we are writing it as 4.8? Sir, because see, after 5 there is a 0, so we need to check the digit before 5. So when we check before 5, it is going to become 4.8. Now similarly here, what is going to happen? So what is the rule? So if it was odd, we have to increase it. If it is even, we have to keep it that way only. So 4.650. So the 6 is even. So when 6 is even, you don't have to increase this digit. You have to keep it in the same. You have to keep it in the same. Okay. Okay. So using these rules, you can do the rounding off of significant figures. So let us take some examples. Okay. Okay. So let's suppose we have 1.352, we have 1.350, we have 1.450, we have 2.67, we have 0, we have we have 2.321, we have 3.450. Okay, it's like this. So in these questions, you have to reduce to two significant numbers. You have to reduce to how many significant numbers, sir? We want to reduce it to two significant numbers. Okay. Okay. Now in the first case, okay, so it is 1.352, so it will become 1.4. Why, sir, it will become 1.4? Because after 3 we have 5. So 5, if it would have been more than 5, we would have written directly 1.4. If it would have been less than 5, we would have kept it 1.3, but it is exactly 5. And after 5, we have a non-zero number. So after 5, when we have a non-zero number, we raise the digit by 1. Okay, so it will become 1.4. Now, sir, it is 1.350. So it is an odd number. So we have to increase it. So how it will become 1.4? Because after 5, we have a 0. After 5, we have a 0. Now, in this case, what we need to do, we need to check the digit before 5 whether it is an odd or it is an even number. So now this is an odd number. So odd number is there, so you need to raise the digit by 1. Now 1.450. Okay, so it will remain 1.4. How it will remain 1.4? Because 1.450 means what? 1.450 means what? That again you are coming to the same situation. After 5 we have a 0. After 5 we have a 0. Now, since after 5 we got a 0, we need to check the number before 5. So, sir, it is an even number, so we keep it the same way. Now, this will become 2.7. How come, sir? So, this is after 0. This is after 0, but for that, this has to be 5 also. Nah? This has to be 5 also. Many students answer this as 2.6. Okay, no, this is not the answer. Okay, so this situation comes only when we have 5 in this place. Now, since it is 7, and clearly 7 is more than 5, so you can increase this 6 by a digit. Okay, by 1. Now, this is 2.321, so it will become 2.3. 3.450, so it will remain 3.4, because again after 5 we got a 0. After 5 we got a 0, and since after 5 we have a 0, we have to check the digit before 5, and since it is an even digit, we keep it the same. We keep it the same way. I hope it is fine to everyone, right? Okay. Now this way you can do the rounding of the significant figures. Okay. So this rounding off will be required in the calculation involving the significant figures, and also when we come to the error analysis. So after significant figures, we are going to talk about a very important concept, that is of errors and their analysis. Okay, now let's come to the calculations in significant figures. Okay, calculations in significant figures. Now, sir, what is important about the calculation in significant figure? What is the what is the idea behind it, what is the need of it, okay, what is the logic behind it, and why it is important part of physics. Now please understand this. So when I talk about significant figures, I tell you about the measurements. Okay, I told you about what? I told you about the measurements. So when we are measuring something, when we are measuring something, okay, when we are measuring something, there is some digits to which we are very much certain about, and some digits we are not sure. Okay, we are not sure about. Okay, like for example, I have this pen. Okay, I have this pen. If I measure it, if I measure it from a normal measure scale, normal meter scale, please understand this. When I measure it from a normal, see, why are you doing this, sir? So, because see, unless you understand in physics, I believe that unless you understand the concept behind something, you understand the need behind something, you are not going to understand the topic completely, because questions can be twisted in any way, and unless you know the concept completely, you are going to feel somewhat, some vacant space will be there in your mind, and from there you can have confusion. Okay, now talking about the calculation in significant figures, so I said let us measure this pen from a meter scale. And if I measure this pen from the meter scale, so how does a meter scale look like? Please understand this. So this is a meter scale. We all have this at our home. So we have something like this, right? We have something like this. Okay. We have something like this. Okay. This is somewhat a meter scale. We all must have seen this. So in this meter scale, we have seen some divisions. We see some divisions. And if I ask you, now please use your common sense and tell me, if I ask you that what is the smallest measurement, what is the smallest measurement with accuracy a meter scale can do? A meter scale can do. So you would say, sir, so this is the minimum length of the object which we can measure with 100% surety, because this is 1 mm or zero point 0.1 centimeter, 0.1 centimeter, right? Right. Okay. Okay. Now please understand this. So I measured this pen from my scale, and I write, let's suppose the pen is 10.3. 10.3. Okay. Okay. So this measurement I can take from the meter scale. Okay. But please understand this. Can you be 100% sure? Can you be 100% sure? Can you be 100% sure that this is the exact reading, this is the true value of this pen? No, sir. It could be little more than 3, 10.3. It could be 10.31. It could be 10.32. It could be 10.33. It could be 10.34. Okay. Okay. But if we are measuring from the meter scale, we are not certain about it. We are not certain about it. So when you are writing the measurement of this through the meter scale, you cannot write like this. You cannot write like this. You can write only up to one decimal place. You can write only up to one decimal place if you are measuring from the meter scale. Why is it so? Why is it so? Because you are only sure that this point 3 would be correct. Okay, this point 3 would be correct. Okay, okay, you are not at all sure. You are not at all sure about this form, whether this decimal place is correct. Sir, if we use one year caliper, I am going to tell you that how we do measurement through one year caliper. But generally, remember, generally the one year caliper can measure zero point zero 0.01 centimeter. 0.01 centimeter. Now, if this pen is measured by the vernier caliper, if this pen is measured by the vernier caliper, and let me say that the reading came out to be 10.34. Now, if from vernier caliper you measured, then you can write this. Okay, then you can write this. Why you can write this? Because vernier caliper can be used to measure with accuracy up to two decimal places. So if you have done the measurement, if you have done if you have done the measurement through vernier caliper to this pen, then you can write 10.34, because this is we are sure of. Okay, this is we are assured of. Okay, this is the correct measurement. But if you measure from the vernier caliper, can you write 10.34? 10 point till this we are assured. But 10.341 can we write? No, sir, we cannot write, because general vernier caliper, although by doing something we can increase the least count or the minimum measurement of the vernier caliper, but the general vernier caliper that is available in the market, okay, that have the least count of 0.01. All right. So now from vernier caliper we can write this, but if you want to do more accurate measurement, if you want to do the more accurate measurement, you can do, if you want to write 10.341 about the measurement, you have to use the screw gauge. Why, sir, we need to use the screw gauge? Because vernier caliper general that is available in the market. Okay. Otherwise, someone will come and comment. So, vernier caliper can have the least count up to 0.0001 as well. Okay, I know it. Okay, I know it. But that is not general. I am saying the standard one. The standard one, the general one that is available in the market. The general one that I am very sure that you have seen in your schools, right? If you ever go to your physics laboratory. Okay, similarly, screw gauge. The general screw gauge available in the market can measure up to 0.001 centimeter. Okay, up to 0.001 centimeter. That is, if you are measuring in terms of centimeter scale, if you are measuring in centimeters, you are going to have the accuracy up to 3 decimal places. So if you are measuring from screw gauge, then you can write 10.341. 10.341. Okay. Okay. Otherwise, you cannot write. Okay. You cannot write. So this is the significance of significance figure in terms of measurement. Okay. So the least count or the accuracy of the measurement, the accuracy of the instrument from which you are taking some measurements tells you about how many significant figures can be there in that particular measurement. Now, I'll tell you one more thing. Let's suppose we have just one important. Okay, this is going to happen because see what I am trying to do. I am trying to develop the base also, the foundation for error analysis. Let's suppose we have a rod AB, then we have joined this rod with BC, okay, and then we have joined this rod with CD. Join this rod with CD, okay. Now this AB we have measured. Let's suppose this AB, length of AB is 10.3. Okay, the length of BC is let's suppose 5.32, and length of CD is let's suppose 6.521. 521. Okay, okay, okay. Now please understand this. So you will get more in the errors, but for timing, I want to ask you a question just to open some, some stems of your mind. Okay, okay. I'll have to ask Harsh sir or Khadija ma'am about that. What are the functions of the mind? I don't know it. I'm not a biologist. Okay, I never studied biology also, right? Sir, you say you are a doctor. I am doctor in mechanical engineering. I am doctor. I have done doctorate from Indian Institute of Technology, Roorkee. I have done masters from Indian Institute of Technology, Roorkee. So I am not that doctor. I am not the doctor of medicine. I am the doctor of philosophy. Okay. Okay. Now let's see this philosophy. So we have A, B, B, C, and C. We have A, B, B, C, and C, D. Now, if I ask you that we have joined all of them, okay, we have joined all of them, okay, okay, or we have joined all of them. So what will be the accuracy? What will be the accuracy of the final measurement? Okay, how accurate would be the final measurement? Okay, what is going to be the accuracy of final measurement? What is the accuracy of final measurement? Okay. Okay. So what is the accuracy of final measurement? Now, please understand this. Please understand this. So, definitely the accuracy of the final measurement depends upon what? Depends upon the least accurate. No, it depends upon the least accurate. Simply, see, just use your logic. See, if we add them, so many students say, so let's simply add them and we'll get something. So definitely when you are adding them in general way, if you are not taking the significant figure thing in your context, so let us add that. So 10.3, 5.32 and 6.521. So you would say, sir, we can add them. We have learned it in the some fourth class. So 336 and 5, that is going to be 11. 336 and this is going to be 11, so this is going to be 1, and this is going to be 6, 6, 12, and this is 1, so it is going to be 22.141. So can you give this as a final answer? Can you give this as a final answer? No, sir, we cannot give it as the final answer. Why so? Because are you certain about it? Are you certain about it? No, sir, we are certain about these two, but we are not certain about that what is going to be at this place. This could be anything, na? Because see, when we are writing 10.3, that means that we have measured from the meter scale. We have measured the AB from the meter scale. We have measured the BC from the vernier caliper because we are writing from two decimal places. And if you see 6.521, that means that we have measured from the screw gauge, right? So we are not sure about it. We are not sure about it. We are not sure about these two figures. Okay. Okay, so what I'm trying to tell you is, because see, all these are interrelated. I'll give you the rules, but first try to understand what is the reason for these rules. So please understand this. Please understand this. Please understand this. So, if in a calculation, if in a calculation, some measurements are involved. Some measurements are involved. Okay. Some measurements are involved. Then in the final calculation, then what is going to happen in the, or I can say the accuracy of the final measurement, depends upon the accuracy of the final measurement depends upon the least accurate measurement, right? Okay. So see, many students think that it must depends upon the most accurate measurement. No. It must depend upon the least accurate measurement. This is the law of the nature. So I hope that you are sitting on a chair or something. No, sir, we are just sleeping, leaning behind and watching your lecture with the popcorn. Just don't do that. You are not going to gain anything. Keep your copy and pen handy. Keep the notes, form your own notes. So see, unless you form your own notes, you are not going to gain anything. Okay? Okay? Our self-written notes are the best. Okay? Okay? I still use my own notes, which I have written some 12, 13 years back. Okay? Okay? Keep updating it, obviously. But I'm still using my own notes, my handwritten notes, no matter what content is available out there. But self notes are the best notes. Okay? Now, please understand. This is the law of the world. So, as I was saying, that when we are sitting on a chair, and let's suppose there are 4 legs to this chair. Okay. Now, if I ask you in general that what is the strength of your chair, what is the maximum weight of a person your chair can bear? So you would say, so it is going to depend upon the weakest leg of the chair, which is going to break the earliest. right? So this is the law of the world. If you think it, if it is the law of the nature, it is the natural thing, right? It is the natural thing. So when you go to the canteen with your friends, what you are eating generally again depends upon that what is the amount carried, what is the minimum amount carried by a student. Okay, okay, this happens or not happen. Okay, so when you are a group of 10, let's suppose, and you are going to canteen to eat something, and you are having 100 rupees, but your friend is having 10 rupees. So are you going to order anything which is more than 10 rupees? Because if you order more than anything which is more than 10 rupees, you have to pay for it. You have to pay for it, right? Right. So obviously, this is the law of nature. Again, you can apply it to anything. You can apply it to anything, right? Okay. So again, when there are measurements involved, the final measurement depends upon the least accurate measurement. The least accurate measurement. Okay, I hope it is fine to you. And this is how you can think of that how significant figures are significant in the world of the physics, because we have understood the physical quantity. So whole of the physics revolves around this physical quantities. We understand this physical quantity one by one. We have understood. We are going to understand some in kinematics, then in law of motion, then in gravitation, then in simple harmonic motion, in properties of solid, fluid, thermal, all of it. Okay, okay, but all of it involves some sort of a measurement. Okay, so this depends. This is the base of everything. Please understand this. Now, please try to understand this. Let me come to the rules of it. So, first of all, we'll write the rules of addition and subtraction. Rules of addition and subtraction. And now I have hoped to given you the logic behind the significant figures. Okay, so rules of addition and subtraction of significant figures. So what are the rules to the addition and subtraction to the significant figures? So the result, please understand, is the rule is the result, please understand, is the result of addition and subtraction. The result of addition and subtraction, addition and subtraction must have the same. The result of addition and subtraction must have the same number, must have the same number of decimal places, must have the same number of decimal places. Remember, decimal places we are writing. Decimal places, not significant figures, as present, because it depends upon the measurement. Na? Okay, as present in the value, as present in the value with least decimal place. Okay, so what does that mean, sir? So if you are, let's suppose, adding three quantities, and they have different digits after decimal. So your final answer must be reduced to, your final answer must be reduced to the the number of decimal places, must be reduced to means must be rounded off, must be rounded off. Rounding off we have seen, no, how to round off. So it must be rounded off to the, it must be rounded off to the decimal, to the decimal places, the value, to the decimal places of the value having the least decimal place. So I'll tell you. So we are going to add, so not significant figure. Okay, okay, not, you are not going to reduce. So let's add, let's suppose 2.24 plus 0.3, 2.24 plus 0.3. Let's suppose 3.28 plus 0.314, 0.314. Okay, okay, let's do that. Let's first do that. Now please understand this. So we don't have to reduce to number of significant figures. We have to reduce to, we have to round off to the decimal places. We have to round off to the decimal places present in the least decimal places value. Okay, now in the first case, so first of all, simply add them. As you know, in general, how you add them. So we have seen it in the first, third class, second class, like that. Okay, I hope all of you are aware of it now. For sir, we don't know addition. You said you will tell from the basic. Okay, so I'm not going to tell you this basic. Okay, I'm going to tell you the basics, but I'm not going to tell you this basic. Okay, please note that. So we have it as 2.54. 2.54. Now, is it the right answer? Are you going to give this as the final answer? Are you going to give this as a final answer? No, sir, we are not going to give this as a final answer because, sir, we have to reduce this answer to one decimal place. We have to reduce this answer to one decimal place. Why we need to reduce this answer to one decimal place? Because we just have learned that in addition or in subtraction, we need to reduce the final answer equals to the number of digits of decimal of the least number of digits of decimal. Okay, you have to reduce it to the decimal places as present in the value with least decimal places. So this is the value with least decimal place. It is having only one decimal place, so you want to reduce it, round off to one decimal place, round off to one decimal place. Okay, sir, how we are going to round off to one decimal place? So you are going to round off in the same way as we have learned to. So, sir, we are going to round off to one decimal place, so it will become 2.5 only. This is going to be your final solution. Why so, sir? Because this is 2.54 after 5. After, so you want to focus this on 5. You have to check this 4. Okay. This is less than 5, so you will keep it in the same. Now let's do this. Let's do this. So I hope you guys are keeping. You guys are doing these things before I do. So we can write it like this: 3.28 is equal to, so 3.314. So what we have done, sir? So add them in a way and check with my addition subtraction also. No, it's long back when I did my fourth or fifth. So right. So 4 and this is 9, this is 5, and this is going to be 3. This is going to be 3. Now please tell me, if this is the final answer, shall we give this as the final answer? No, sir. We must round it up to one decimal place. No, we must round off to two decimal places. Why, sir, we must round it off to two decimal places? Sir, we need to round it off to two decimal places because we have learned that whenever we are adding or subtracting, the final answer should be rounded off to the number of decimal places present in the value of the least present in the value with the least decimal place. Okay. So what is the value in the least decimal place? So it is 3.28. So the least decimal place is 2. So this is 3. So we want to round it off to two decimal places. So it must be 3.59. Sir, why it is 3.59? Sir, because this is less than 4. This is less than 4. And what if it would have been 6 here? So we would have written it as 60 because 9 is raised to 10. So one will go to the other, it will become 60, obviously. Okay, so what is the answer? The answer is 3.59 here. Now let's take some more questions. Any random thing you can do. Okay. Okay. And meanwhile, you tell me what is the number of significant figure in the first, second, and third? How many significant figures are there in the first? Let's see how much you remember the last session. where we have learned how to identify the significant figure in our value. Now, in the first one, the number of significant figures is 3. Why? Because all the non-zero digits in a value are significant always. In the second case, again, we have 3 significant figures because in while seeing the value of significant figures, all the non-zero digits are always significant. So in the second case, 1.12, there are 3 significant figures. Now in the third case, we have 0.03. Now in this, how many significant figures are there? So there is only one significant figure. There is only one significant figure. Why so? Because leading zero or initial zeros are never significant. Okay? Okay? So sir, here we have to reduce it to one significant figure. No, 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 no. This is going to be the confusion that you are going to have later on. We are not rounding off to the minimum significant figure. We are rounding off, again I am telling you, to the decimal places as with the value having the least decimal places. So final answer would be having the decimal places up to 2 digits. Up to 2 digits. Right. Right. And now if you try to understand this in this context, when I told you, so this you cannot write now. So what could be 22.1? The final measurement with 100% surety, you can tell that this is going to be 22.1. You are not sure about this 4 and 1. Right? Okay. So I hope you are getting the context and you are getting it practically also. When we see things the practically, in IIT we are told that the things which are understood by means of practicality last long. Okay. It never goes out of our mind. Right. So now it is 0.331, 1.12, 0.03, 1.12, and 0.03. Okay, 0.03. So this is going to be 1, 3, 2, 6, and this is going to be 8, 4, and 1. So 1.481. So normally when we add this, you are going to get this. But is it your final answer? No, sir. We need to round this off. We need to round this off to 2 decimal places. 2 decimal places. So when we round this off to 2 decimal places, we are going to get 1.48. 1.48. Okay, 1.48. I hope it is fine to everyone. I hope it is fine to everyone. Okay. Okay. Now please understand this. Let's suppose we are having a box. Okay, let's do like this. We are having a box. Okay, so how can the questions can be made? So we are having a box of, let's suppose, 1.8 kg. Okay, the box is having a weight of 1.8 kg or mass of 1.8 kg. Okay, and in this we are putting another, let's suppose we are putting a balloon. Okay, we have placed an balloon. Pardon my skills of, drawing. Okay, this looks more like a balloon. Okay, so this is a balloon. Okay, and this balloon weighs, let's suppose, 1.12 gram. 1.12 gram. Now, if I ask you, what is the net weight? What is the net weight of this box? What is the net mass of this box? What is the net mass of the box? What is the net mass of the box? So how we are going to do that? How we are going to do that? Okay, how we are going to do that? Let's try to do it. Let's try to do it. Let's try to do it. So how can we do it? How can we do it? How we are going to have it done? Now please understand. Now please understand this. So first of all, we have to make the conversion of the unit. Okay. we have to make the conversion of the unit. And while converting the unit, you have to make sure that the number of significant figures remain the same. This is the rule we have seen now. While converting the unit from one system to another, you must ensure that the number of significant figures remain the same. Okay, so we can change this 1.12 grams. So let's say the mass of the balloon. Okay, mass of the balloon. So we can write it as 0.00001. Okay, 0.00112. Okay, kg, right? Okay, okay. Now see, the number of significant figures remain the same. Now many students, what they do, so they write mass of the box, they convert it into grams, so they multiply it with 1000, so they say 1800 grams, 1800 grams. Okay, okay, and then they add it. So in this, see, you are going to mistake is going to occur, because you cannot write like this 1800.0. So the decimal place will go, and you are more likely to get the wrong answer. So whenever you are converting, for ease, there is a way to do that also. I'm not going to tell you that, I don't want to confuse you. So there is a way to that also, but see, this is going to be simpler, because see, you are having the decimal places, so you can simply add them. Now, obviously, the way net mass of the box is going to be that mass of the box is going to be the summation of the mass of the box and the balloon inside it. So that means it is going to be 1.8 into 0.00112, 0.00112. So what we are going to get? We are going to get 1.80112. So is this the final answer? Is this the final answer? No, sir, this is not going to be the final answer, because we want to reduce this. We must round this off to one decimal place, because we understood in addition and subtraction, the final value must be rounded off to the decimal places as present in the value with least decimal place, as present in the value with least decimal place. So what we are going to get from here? So we are going to get 1.8. So 1.8 is going to be your final solution, your final answer to this. Now let's take one more case. Let's take one more case. So let's suppose we have 2.5 into 10 to the power 4 minus, we have done addition a lot, minus 2.3 into 10 to the power 3. 10 to the power 3. So how we are going to do that? How we are going to do that? So let's write it as 2.50000. We can't do that. We can't do that, because see, if you write it like this, 2.50000, is it the right way to writing this? No, sir, this is not the right way, because see, 10 to the power 4. So what we have learned? We have learned the order of magnitude is never significant. The order of magnitude is never significant. So if you write this that way, you are going to have the wrong conversion. The significant figures are going to get changed, so you are not going to have it happen. So what we are going to do? We are going to write 2.5 into 10 to the power 4 minus. Okay, let it be. Now, can we convert this 10 to the power 3 to 10 to the power 4? Yes, sir, certainly. How? So if we write it as 0.23. 0.23. So in this conversion, you can see that the number of significant figures haven't changed. Number of significant figure haven't changed. Okay. So obviously, when you want to do addition and subtraction between two values having some order of magnitude, you must bring them to the same order of magnitude. You must bring them to the same order of magnitude, because unless you bring them to the same order of magnitude, you are not going to add them or subtract. This is the very basic. So now simply we can do it. So it will be 2.5, 0.23. So how we do it? Carry forwards, or how to take carry forward. So this will become 4. This is going to be 10. So this will become 7. This has become 7. This has become 2. This has become 2. And this has become 2.27. 2.27 into 10 to the power 4. So this is going to be the final answer. Is it? Is it going to be the final answer? Is it going to be the final answer? No, it is not going to be the final answer, because in addition or subtraction, we must round off the final answer to the number of decimal places as present in the value having the least decimal places. Okay, so here it is going to become 2.3 into 10 to the power 4. 2.3 into 10 to the power 4. This is going to be a final answer, because we want to reduce it to the decimal places as present in the value with the least decimal places. Okay, okay. So guys, remember, this is going to be used in the next topic, that is error and its analysis as well. Okay, okay, okay. Now the addition subtraction is done. Okay, there can be n number of problems that you can do. Okay, so addition and subtraction can be done. Addition and subtraction is done. Now addition, subtraction, after addition and subtraction, so you must have observed that addition and subtraction had the same rules of calculation for significant figures. Yeah, is it or isn't it? Yes, sir, they have the same rules of addition and subtraction. Now coming to multiplication and division. Now likewise they also have the same rule of multiplication and division, have the same rules of calculation of of significant figures. Okay, very easy, very easy. Okay, okay. Now, so in addition and subtraction, what we have done? In addition and subtraction, guys, what we have done? So in addition and subtraction, we have first added or subtracted in the normal way, then we reduced, then we rounded off, then we rounded off the final value to same as the number of decimal places present with the least value. Okay, present with the value of least decimal. Okay, okay. Now in multiplication division, what we are going to do, or what we must do, we must to firstly simply multiply and divide them, as we know to do. Okay, when we simply multiply and divide them, we are going to get some value. Now the final answer shall be reduced to the least number of significant figures as present in any of the value. Okay, let's suppose that you have multiplied two values and you are getting some final answer. Let's suppose you are dividing dividing two values, and you are getting a final value. Okay, then the final value must have the same number of significant figures here, not the decimal places. That is the key. Okay, don't get confused. In addition and subtraction, we come down the final answer to the number of decimal places as present in the value having the least decimal places. Here we are rounding of the final answer to the least significant figure present in the value. Okay, okay. So firstly multiply or divide in normal way. Firstly multiply or divide in normal way. Okay, secondly, the final solution must be rounded off. The final solution must be rounded off must be rounded off to the the number of significant figures, to the number of significant figures significant figures as present as present in the value with least with the least significant figure. Okay, with least significant figure. Do remember this. So here in the case of multiplication and division, we reduce the final solution. To the minimum number of significant figures as present in the values we are multiplying or dividing. I hope it is fine to everyone. And in the case of addition and subtraction, let me mark it least decimal place. Okay, both are different. Okay, here in addition and subtraction, we uh, reduce the round off to the decimal places present with the value of least decimal place, and here we are reducing in multiplication and division. We are reducing it to the least significant figure. We are reducing with the least significant figure. We are rounding off to the least significant figure. That is the basic difference. Now let's do some very simple. No? I'll do one or two questions. So let's suppose 2.1, 2.1. If we multiply them, what we are going to get? Okay. So 21, 21, that is 441. So we are going to get 4.41. 4.41. So is this the final answer? With time, you are going to say this is the final answer. This is not the final answer, guys. This is not the final answer. What is the final answer? The final answer is 4.4 because we have to round off to minimum significant, least significant figures. So how many least significant figures are there? So two significant figures are there. So we have to reduce the final solution to two significant figures. Now we have, let's suppose one more question, let us take. Let's suppose we have 142.06 into 0.23 into 0.23. Okay. Now let's solve this one. So what is the multiplication we are getting? Let me multiply it using the calculator. So why you are not multiplying like this? Because I don't have to give the NEET examination. No, you have to. So you have to multiply like this. I can take the privilege of being a teacher. So we are getting 32.678. We are getting 32.6728. Okay. By the calculator, I got this idea. I got this value. Using the calculator, I got this value. So, sir, calculator must be correct, no? So, no, it is not that correct. We have to stick to our concept. So, we must reduce it to how many significant figures? So, we have to round off to two significant figures. Why, sir, we need to round off to two significant figures? Because we are multiplying these two values. So, the final answer must carry the same number of significant figures as carried by the value having the least significant figure. Okay, so when we round this off to two significant figures, we are getting 33. How, sir? So 32, this is 6. If 6 would have been less than 5, if this place would have been less than 5, we would have kept it as 32. Now since it is more than 5, we are giving it as 32. We are doing it as 32. Now let's suppose we have 0.6 divided by any number you can take, no? 7.27. Okay, so let's divide 0.6 by 7.27. How we are going to do it? Sir, again you are going to cheat us. You are going to use the calculator. Why, sir, you are using the calculator? Because I don't have to give the NEET examination, right? Okay, so we are getting 0.08. While using the calculator, I get this number. 98253095. So is it the final answer? No, sir, this is not going to be the final answer because we need to round off to one significant figure. We need to round off to one significant figure. Okay. 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 So why we need to round off to one significant figure? Because obviously we are dividing these two values. So the final solution must be rounded off to the significant figures as present in the value with the least significant figure. So when we round this off to one significant figure, we are getting 0.1. So this is going to be the final solution. So guys, in this session, we have learned the calculations involved in the significant figures. In the last session, we have learned the rules of significant figures. Okay, rules of significant figures. And in this session, we have learned about how do we round off the significant figure, how do we do addition to significant figure, how do we do subtraction to significant figure. Okay, okay, and I am hoping I'm hoping that I'm hoping that this section is clear to all of you. So guys, with this I would say thank you very much for watching this session. Please share amongst your friends also, share amongst other people also, so that everyone can get benefited. And also I would request in the last that don't forget to subscribe the channel. Okay, so with this, thank you very much, have a good day, and I'm going to see you in the next session where I'll be talking about the errors and their analysis. Okay, very important chapter, very frequently asked chapter, asked topic. Okay, so don't miss the next session. So see you soon. Please hit the subscribe button so that you get the notifications of the new video. Okay, so thank you very much, have a good day.